This video is going to be about the transfer of the sun's energy. Now let's talk about the Earth's climate system, the global climate system, and how it interacts with the sun. The Earth's climate system is also known as a complex set of components that interact with each other to produce Earth's climate. This includes air, land, liquid water, ice, and living things. So the major components are water and ice, land, air, and living things, such as a tree. The climate system is powered by the sun. The interactions between these components, all of these components, and the sun produce climate zones. I will teach you about the energy Earth receives from the sun and what happens to this energy on Earth. Almost all energy on Earth comes from the sun. The sun emits a number of different types of radiation. UV stands for ultraviolet, and UV radiation is an invisible short wavelength, higher energy radiation. The second one is called infrared radiation. This is an invisible long wavelength. Now this was ultraviolet was short wavelength and a higher energy radiation. Infrared is a long wavelength, lower energy radiation. And the last one is called visible light. These factors will later come into play when we talk about the balance of energy on Earth. How does Earth absorb energy from the sun? I will draw an incoming solar energy ray, and this is 100% of the energy. We will now see how the 100% of energy gets divided into different percentages, and what percent gets absorbed and what percent gets reflected off the Earth. Here I'll draw some clouds. Here is our atmosphere. And let's see how this all works out together. So out of the 100%, first the 6% gets reflected by the atmosphere. That's 6%. Now 20% gets reflected by clouds. That's 20%. Now 4% gets reflected directly from the Earth's surface. That's 4%. These all add up to 30%. 30% out of the 100% of solar energy from the sun gets reflected off the Earth. Let's see what gets absorbed into the Earth. 51% is absorbed by land and oceans. Land and oceans. 19% is absorbed by the atmosphere and clouds. Atmosphere, clouds. Now these add up to 70%. And you can see that these two add up to 100% of energy that originally came from the sun. I'll pull up a better diagram of this situation because this is kind of hard to understand. Now let's think about a thermostat. A thermostat switches off the heating system once your home has reached a set temperature. Imagine what would happen if the thermostat broke and the heating system continued to heat the house. What would happen to the temperature of your house? It would overheat.
Yes, science!
The same thing would happen to the Earth if the Earth continuously absorbed the energy from the sun and not let any of it out. Now, how does the Earth's average temperature remain relatively constant? Earth's surface emits energy. Remember the three different types of radiation that is in solar energy? When the Earth's surface emits energy, it emits mostly lower energy infrared radiation back out. Now here's a simple diagram that illustrates both the energy absorbed by the Earth and atmosphere and the energy radiated back again by Earth and the atmosphere. What happens is that 51% of the absorbed energy gets divided into 45% and 6%. The 6% is radiated directly to space from Earth. 45% is indirect radiation from Earth. The 45% combines with the 19% that was initially absorbed by the atmosphere, and the 64% gets radiated to space from clouds, atmosphere, and indirectly from Earth, all combined. Now, how is this linked to climate change? When the factors of the sun's energy transfer process gets manipulated, for example, increase or decrease in the sun's temperature, thickness of the ozone layer, greenhouse gas levels in the atmosphere, then the Earth's climate can change. Basically, 51% of the energy absorbed by land and oceans, and 19% of the energy absorbed by atmosphere and clouds, they all combine together at the end. They come in like this. At the end, they all get emitted back to space. This gets combined in the process. So, incoming energy equals 70%. Well, incoming energy is 100%. But absorbed energy is 70%. And later emitted energy is also 70%. This is how the Earth keeps its balance. Now, the last thing I'm going to talk about is the effect of latitude on climate zones. Now, what is latitude? Latitude is a measure of distance from the equator. For example, Nigeria has a lower latitude than Greenland. This is Nigeria. See how it's close to since it's close to the equator, it has a lower latitude. On the other hand, Greenland is located around here. It's quite far from the equator. This is why it has a higher latitude. Nigeria is a lot warmer than Greenland. This is because of two reasons. Let's focus on why Nigeria is warmer than Greenland. The first reason is because near the equator the sun shines directly overhead. There the energy from the sun is spread over a small area and feels very strong. So a smaller surface area. The second reason is because at lower latitudes, the sun shines directly on Earth's surface. Radiation from the sun passes through less of the atmosphere, and less radiation is absorbed and reflected. Here's a diagram that can illustrate the first point. This is the incoming sunlight. I will show the example of Nigeria first. If you focused on Nigeria only, sunlight coming to Nigeria, if you look at the surface where the sunlight meets Nigeria, it is very small, which means that it's spread over a small area and feels very strong. On the other hand, if you draw Greenland, the sunlight hits Greenland at an angle, and it is a much larger area. This means that it's spread over a larger area and feels weaker. Also, because the radiation hits this surface at an angle, this surface is at an angle. The sun's radiation must pass through more of the atmosphere before it strikes Earth's surface. For Nigeria, it hits it straight away, which means it passes through less of the atmosphere and less radiation is absorbed and reflected. To summarize the lesson, these are the two main points that you should remember. First, the energy absorbed equals the energy emitted. 70% of the incoming solar energy gets absorbed into the Earth, and 70% is emitted to keep a stable temperature of the Earth. This is how the Earth keeps its balance. The second point is that climate changes with latitude because, first, places close to the equator receive sunlight from directly overhead. The sunlight doesn't have to spread out, which means that the sunlight feels stronger with lower latitudes. With higher latitudes, the sunlight has to spread out over a larger area, which means the sunlight feels weaker there. The second point is the more angle, the more atmosphere the sunlight has to pass through. Therefore, at lower altitudes, where the sun shines directly on the Earth's surface, radiation from the sun passes through much less of the atmosphere and less radiation is absorbed and reflected. Now that's the end of my video. Thank you for watching.